Yeah, students. In the previous class, we discussed about a scenario 1. Now we are going to discuss about the scenario 2. As I told you in the previous class also, there are three hyperplane. One is A, B, and C. All the three have segregated the classes, both the classes perfectly, better way compared to the other graph in the previous class graph. Now in this three, all the three are best, excellent, equally segregated, but out of these three, which one will be called as the best one? By seeing the distance, by checking out the margin. So that we are going to learn in this class today. Now you see. Now whenever I say above, you can see that the margin of hyperplane C is high as compared to both A and B. Hence we name the right hyperplane as C. Another reason of selecting the hyperplane C is that the margin is robustness. If we select a hyperplane having a low margin, then there is a high chance of misclassification. Clear? Now what I want to say here is, I will show you one small image to you, one word file of your notes where you can justify. So according to me, here you can see C is the better compared to A and B. How it is compared to A and B is, I want to justify within one small notes. Clear? See here, please see the notes. So what I want to say here, please see these notes, this diagram. Everybody, I hope you can see this diagram. See here, I have marked out a black dashed line. How many reds I have marked for A? Can you see? 1. And how many for C? Okay, 1 star. And B, you see 1 star. Now you see the distance of a red, approximately A and C almost looks like C. Almost looks like of same distance in the measurement unit. When I see for a C, how many are there here? It is little bit larger. So what I want to say here, you see here, you can see that the margin for hyper C is high as compared to both A and B. So my dear students, whenever we say A, B, C, all the three are a best right hyperline. But out of these three, which one is called as the most better? Means you recommend based on the line, you based on the length, based on the margin. If the margin is high, consider it as a best. Another way, the lightning reason for selecting the hyperplane with the higher margin is robustness. Why you are selecting only the high yield range? Means it is proven that if there is a higher margin is there, then there is a lower margin will have a high chance of misclassification. Means higher the margin, you will have more classification chances. If there is a lower the margin, there is a high chance of misclassification. Our target is of a classification rather than the misclassification. Understood? So why we have chosen C rather than A and B? Clear? So what I want to conclude, C is having a higher, which is having a higher margin robustness. Higher margin robustness compared to A and B. If there is a more higher robustness, there is a very less misclassification. Our target is we must have a high classification. So if you want to have a high classification, you must have a high margin. Clear? So because of this, in the scenario 2, we have taken C as a best margin robustness. Clear? Now we will move on to our slide. Clear? So here we discussed in the previous class, C is a higher margin. Clear? So now we will move on to the third scenario. What is the third scenario says? Now identifying the third scenario, use the rules as discussed in the previous section to identify the right hyperplane. So what I want to say in the scenario 3, you apply scenario 1, you apply scenario 2, and then you compare. So when I apply the scenario 1 says that there should be a better segregation between the two vectors, that is sector was scenario 1. In a scenario 2, identify the higher margin such that whenever there is a higher margin, there is a less misclassifications you can obtain. So that is the scenario 2. Now we will see the scenario 3. Some of you may have selected the hyperplane B as it has a higher margin compared to A, but there is a catch, that is SVM selects the hyperplane which classifies the classes accurately prior to maximizing the margin. That means here hyperplane B has a classification error and hyperplane A has a classified all correctly. Therefore the right hyperplane is A. Can you observe the image? See here, hyperplane A and hyperplane B. Now if the situation like this, how you will see? You have to segregate scenario 1, segregate properly and see the higher margin. So whenever I say A and B, there is a scattering point, scatter plot. You can see the star. The star is having higher margin of an A and compared to the remaining B hyperplane. So I think single star, everybody can see the graph. A single graph is between A line and B line. Clear? And whenever I focus only with respect to B, if I see, if with respect to B, if I see, this a single line will have a maybe high margin compared to the remaining all stars. So when I compare these circles, the circles of all the, with respect to B I am talking, all the things may be having a lesser margin. So probability is having, B is having a less margin compared to A. So in this way we will conclude combination of scenario 1 and scenario 2 will leads to a scenario 3 where we will have a higher margin. Misclassification will have a very less. So this is about a third case study. Clear? About a scenario. Now we can we classify the two classes? This is a scenario 4. Below I am unable to segregate the two classes using the straight line, as one of the star lies in the territory of others, that is on the circle. Clear? Now this is not a XY graph, it is a complete 4 coordinates graph where you can see circles are at the near to the origin and stars are away to the origin. But whenever I see the quadrant, if I see the quadrant of plus plus coordinate, there is a circles and there is a star. Similarly, if I see the second coordinate, like in a plus and minus, there is a both stars and circles. Similarly, if I see the minus minus coordinate or in a minus plus coordinate, both are there. So what I want to say in this image, the circles and stars are unable to segregate because both are lies in the territory of circles, both are lies in the territory of stars. Now how to take a decision if the vectors are like this? Now as I have already mentioned, one star at the other end is like an outlier for star class. That means the SVM algorithm has a future to ignore the outliers and find the hyperplane